support you as you complete your Bubble Lab conclusion, this video cast tells you how to cite data from a position versus time graph to support an observation about the bubble tube's velocity. This can also be generalized to citing data off of any position time graph to back up what you believe you are able to conclude about velocity. So let's start with what we can tell from these two graphs. So if we have this graph, then this line A is the steepest, line F is steepest on the other graph. So based on the steepness of the line, the steepest line on a position time graph represents the fastest velocity. Line A represents a positive velocity, line F represents a negative velocity. However, in both cases, A and F are the steepest line, regardless of whether they have a positive or a negative slope. They're both the steepest line on their respective graphs. So A is the steepest on the graph here on the left, and F is the steepest on the one on the right. Therefore, A is the fastest object represented here, and F is the fastest object represented there. We can make this evaluation without regard to direction. But how do you cite data from a position time graph like this to support an observation about the bubble tube's velocity? This method is observational that I just showed you, and it's helpful. You'll certainly want to remember and use this method when it's possible to simply come up with a comparison between objects. However, it does not meet the criteria for citing data. So we're going to make our way through how to do that. This is the example on the handout that you received. So you would begin with a graph like this by selecting a time that includes position information for A, B, and C. So I want to look through at a position where a time where I can pull off a position for each one. If I go out here to 3 seconds, I can find a position for object C at 3 seconds, but at 3 seconds there is no position information for A or B. So that's too far along the time axis. If I came back to 2 seconds, I could get position information for object C and object B, but not for object A. So we have to move all the way back to closer to the front of the graph. It happens at 1 second we can get position information for both C, B, and A. So that's going to be the position where we start. So at 1 second, we're going to highlight the graph at 1 second so that we'll be able to pull off the position information seen for C, B, and A at the same time interval. So that's an easy thing to do next as we switch down here to record those positions. So at 1 second, the position of object A is 9 meters, so we record that. At 3 seconds, the position of at 1 second, the position of object B is 3 meters. Then lastly, at 1 second, the position of object C is 1 meter. So we've recorded the relative positions of each of the three objects at the same time interval. So to make a statement about that, we can begin by, we have to put this into sentences so that we have a sentence that shows everything we know and backs up our observation. So we're going to begin by stating a fact about position time graphs. So by comparing the displacement of objects in equal time intervals, the object that covers the most distance is the fastest. Object A covers 9 meters in 1 second, object B covered only 3 meters, and object C covered only 1 meter, proving that object A is fastest. Object A is faster than object B or C. So hopefully that pattern will help you as you craft the conclusion that you need to write on the final section of your Bubble Lab.